Today we have two panelists who are ophthalmologists in France. So first, Dr. Céline Faure. Hello.
Hello.
Céline Faure is ophthalmologist at Hôpital Saint-Martin in Caen and a former attached practitioner at 15 Hospital in Paris. And she conducted a very interesting prospective study on chronic kidney disease patients using adaptive optics retinal imaging. And this study has just been published, and she's here to talk about it today. And our second panelist is Professor Michel Pack. Hello. Michel Pack is a professor of ophthalmology and director of the Clinical Investigation Center at 15 National Eye Hospital in Paris. He is a leading expert in adaptive optics retinal imaging, and he pioneered applications in clinical research for a wide range of retinal diseases, as well as systemic conditions such as arterial hypertension. So for today's event, Dr. Faure and Professor Pack, they very kindly agreed to share their vision and how they have been using Imagineye's adaptive optics camera, the RTX1 device, in their clinical research projects. So for those who don't know at all, the RTX1 camera. So the RTX1 camera is a device that enables to image the patient's retina at the cellular and microvascular scale, thanks to adaptive optics technology. So just very briefly, in this healthy eye, what is interesting is that we see the very detailed structure of the retinal arteriole. And this device enables measuring with micrometric precision the lumen of the vessels and the wall-to-lumen ratio, as well as other metrics. So I won't be talking more about the RTX1 because we will have our panelists who have many things to say. So Céline and Michel, in clinical research, retinal imaging, such as color fundus images, is increasingly investigated as a tool for providing a window into the body and brain. What inspired you to use adaptive optics imaging of the retina for investigating systemic conditions? So first, Michel.
So thanks to the RTX1, we had access to unique parameters, which are the vessel itself. Because when you look at the fundus with your own eyes on correct fundus photographs, you only see the red cells flowing into vessel, but you don't see the vessel itself. And the vessel itself, the wall, contains information related, for instance, to arterial hypertension. So you can only, if you look only at the red cell column, you can only detect some narrowing of local narrowing of artery, but not the direct cause of this narrowing, which is maybe vasoconstriction, or it can also be thickening of the wall. So in order to better understand what's actually happening in vessels, you need to look at their parameters. So, and this may not affect vision. That's why it's maybe a good indicator of general health, starting, of course, with arterial hypertension, but also diabetes and other diseases. We studied, and I'll mention that at the end of the talk, the possibility to explore neurovascular diseases through the eye, because we have unique access to microvessels that are also the same function and structure in the brain as well. So it opens up a renewal of the interest of the eye as an indicator of general health.
Thank you. And Céline, can you tell us a bit more about what inspired you to do this study in Caen?
I'm going to focus on chronic kidney disease patients. And I think the inspiration came from two different factors. First, it is very important to know that the patients with chronic kidney disease are very special patients. They have to deal with very high cardiovascular morbidity and mortality that is not fully explained by traditional cardiovascular risk factor. And to give you just a quick example, people with moderate kidney disease at 2 or 3-fold a higher risk of cardiovascular disease than people without kidney disease, and this risk is even greater when it's when we are dealing with end-stage chronic kidney disease. For instance, people who are on hemodialysis. So it's a very special population, and I think there was no many studies on this population. So that was first maybe point, and secondly, the microvascular microvasculature in the kidney and in the retina are sharing a lot of similarities. They are both microvascular end organs supplied by very small caliber arteries, and it's very important to know that both tissues are very well have a very well auto regulations. So it was, I think, for these two reasons, we wanted to study this population.
Thank you. So, well, could you tell us about what you observed in this study and what were the main findings from imaging?